Hello everyone, and welcome to a new session on connection design using RAM connection. My name is Surajit Ghosh, and in this session, I'll cover RAM connection standalone version. It is an isolated connection design module which does not require any 3D analysis model. It is basically used for quick checking and design purpose. Similar to any in-house application, we can provide all required inputs here, like the geometric and section information, load, connection data. In this model, I have designed multiple connections manually using the standalone module. All connections are grouped properly like shear, moment and gusset connection. For each joint, we need to provide section and load information manually. Also, we can copy it from another joint. For example, I can copy this beam column flange joint with section and load data. For this joint, an ISMB 400 section is used as beam and ISHB 300 is used as column. Apart from a prismatic section, we can use a tapered member or a prismatic beam with additional haunch to handle excessive force at the joint. This beam is perpendicular to the column. We can also assign any slope in the vertical axis and skew angle in the horizontal plane. In such case, a bent plate connection will be assigned at the joint. Next, we need to specify the load component required for design. For any shear connection, we can specify only uniaxial shear and axial force in the beam. For moment connection, axial and moment values are required, and for a combined connection, all these three force components are required. There are several other components, few of which are code specific like Mmax and MLT are used only for BS code. Column loads are used for specific check. We can copy paste the data from any Excel or CSV file and use it for design. I want to design this joint as a side plate or shear tap connection using IS 800-2007 design code. These primary and combination loads will be considered for design. For AISC, we can provide seismic design parameters, not for Indian code. Next step is to assign the side plate connection at this joint. As discussed earlier, either we can select this from basic connection, which will use a predefined template for design, or we can use a smart connection, where program will optimize the connection. Available templates are code dependent. There are several other templates like a gusset connection or base plate connection which are not relevant to this joint. All those irrelevant connection templates are already filtered out. We can select website plate template and assign it to this joint. As you can notice, program already designed this connection with utilization ratio 0.75. If required, we can further customize it or change the connection data from the connection pad. In this interface, except the predefined geometric and load data, all other information are customizable. We can assign coping in the top or bottom flange, modify the plate thickness, position of the connecting plate on the beam, change the bolt specification. Standard bolts from Indian database are listed here. We can select from other country as well or add a custom bolt which is project specific. Change the number of bolts in a row and number of column. We can also change the pitch or the standard bolt hole to oversized or slotted hole in horizontal or vertical direction. One thing to note, if we change any of this information, program instantly redesign the joint and report the modified utilization ratio. As the bolt number is reduced to 3, utilization ratio is increased to 0.99, which seems okay, but few geometric checks are now failed as indicated by this amber color. We can confirm this from the design report, which provides design summary and calculations for geometric and strain check. For this joint, 2 geometric checks are failed due to 3 bolt rows, though all other design checks are passed. If we want more information about any of these checks, we can switch on the design formula, which includes all relevant calculation steps along with equation in the report. As you can see, whatever value is reported in the summary, all are now clarified with code reference. This can be saved as Word, Excel or text file. Not only this, a drawing file is also generated with different view of the connection with details. It is just like a drafting drawing and instantly updated if there is any change in the user input. We can save this as an external DXF file. Similarly, we can design any moment connection, a combined connection with moment and shear templates assigned separately, or a gusset connection with a column, beam and 2 bracing member, or beam and brace in both sides of the column. Gusset connection is one of the most advanced connections where different forces from the members are resolved and combined, which is used to check the connection strength at different interface, like where the beam is connected to the column or gusset, where the brace is connected to the gusset. All these connections are customizable. If we want to change the bolted brace to gusset connection to a welded connection, we can do that easily. Or change this gusset to beam connection from welded to angle connection. Even change the side angle beam to column connection to a side plate connection. Accordingly, program designs this joint, generate the drawing and report file. That's all about the standalone module. Though we need to provide few inputs for connection design, still this module is useful for quick check of connection strength or to validate the results and generate report and drawing. By the way, in RAM Connection 2024, we can change the assigned section directly from the UI. Both for beam and column, sections from same database are available. For example, as an ISMB section is used for beam, relevant ISMB sections from Indian database are available in this dropdown. We can select any section. Program instantly redesigns the joint and reports the updated ratio. In RAM Connection Standalone, no separate design is required. Everything is linked with the joint and any modification of geometry or load triggers the design. In this module, we can also generate a combined report for all joints. This report can include joint input and load information for every joint present in this file. Along with this, we can generate a design report using this connection detail option. This creates a detailed report for all joints, starting with the joint and load data, then geometric and capacity check ratio. If required, we can switch on the view formulas option to include all intermediate calculations, similar to individual report file. This is the most detailed connection design output. We can save it as a Word, Excel or text file. Also, we can generate a report for all connection elements used in this file, like gusset plate or bolt. First, a summary of the connector is reported. For angles, plates which are used as gusset plate or connector, followed by the details of bolts, anchor bolts for base plate connection, and weld. We can use this report for quantity estimation or procurement purpose. Even send this data to Excel for BOQ generation. This connection summary is followed by a report of individual connection. There are two more useful output. First one is a 3D view of the joint, which we can save as an image file. This file contains the joint picture as well as some information of the section. We can use this in the report. Along with this, we can also save the connection drafting drawing as an external DXF file. This file can be opened later for editing using any CAD software like MicroStation or AutoCAD. That's all about RAM connection standalone. In the next part, we will discover how we can customize the connection database of this module. Thanks for watching.